So student council decides to form a subcommittee of 5 council members. How many people are we choosing? 5. To look at how funds should be raised, how funds raised should be spent on the students of the school. There are a total of 11 student council members, 5 males and 6 females. So we have subgroups. What are my 2 subgroups, Holly? Males and bucket. In this subgroup are males and females. Sabrina, how many males are there in the bucket grand total? Read the question. 5. How many females? Okay. And how many people are we picking grand total, Sabrina? That's how many people there are. How many people are we picking? How many people are we choosing? 5. Okay. In A, how many are females, Sabrina? So by reasoning, if there's 3 females, how many must be males, Sabrina? 2, because we're choosing 5 people. Yes, 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 yes. Can you guys remember this little trick? So this is my bucket trick. Can you remember the equation, Amanda? You see what's going to pop out of here? What choose what? What choose what? And means multiply. So 5 males choose 2 of them, and 6 females choose 3 of them. Okay, how many? 200? Yeah? Steph, what's the difference between A and B? 2 key words in B. At least. What does at least 3 mean? I'll give you a hint. It means 3 or. I want you to list them all. 3 or what? 4 or 5 or. Wait a minute. Although there's 6 females, am I allowed to choose 6 females? No, because I stop at 5 people. So I would write 3 underlined or 4 underlined or 5 underlined. Those are my cases. 3, Katie, I've already done, but in our notes I'll rewrite it. 3 was 5 choose 2, 6 choose 3. What does or mean in combinatorics? Add plus. And I think now what I would do is I would be a bit clever. I drew a lovely bucket. Now I want to pick 4 females. Katie, I would just do this. Cross out the 3, make it a 4. And then by reasoning, instead of 2 males, how many males am I picking? 3 or 1? 1. Oh, I guess this expression is going to be 5 choose 1, 6 choose 4. Or, and Cassandra, I would do the same trick. I would cross out the 4 and I would say, oh, how many females am I picking for this case? Shannon? 5. And by reasoning, how many females am I picking? 5. How many males am I picking? None. What's my expression here going to be? Okay. That's how you can reuse a bucket without redrawing it. Nice trick. Oh, and then I would go to my calculator and I would say, I'll type in the first expression, but I won't type all 3 in at once. Instead, I'll go 5, choose 2, and 6, choose 3, which I know I had that answer from A, but in case I didn't, that's 200. And then, Sabrina, you remember what we did last day to be clever? Save ourselves some typing? I went, second function, enter, bring that one back, because all I want to do is I want to change this 2 to a what? To a 1, and change this 3 to a, yeah, 75 plus 5, second function, oh, clear, second function, enter. Change the 1 to a 0, change the 4 to a 5, 6. 200 plus 75 plus 6, 281, I think, yeah. C. At least 1 female. How could I do that? Well, what are the cases? I'll give you a hint. 1 or 2 or. Okay, I could do that. It'd be 5 expressions, and there's nothing wrong with that. That's a lot of work. Anybody see a shorter way to do that? Amanda, what? Okay, one fairly short way to be to do 1 or 2 and then add 281, because 281 is or 3 or 4 or 5. There's an even shorter way to do that, specifically because they're asking me at least one. What's the opposite of at least one female? I don't think all of them. What's the opposite of at least one? Isn't it none? See, I think another way to do this, the shortest way to do this would be find the total number of groups minus how many groups have no females. Whatever's left must have at least one female. In fact, we're going to write this. Total number of groups minus number of groups with 0 females equals at least one female. It's called the complement. Remember, a few times, Katie, what we've done is if they've asked us a question saying if something can't happen, we've said, find how many where it can happen and subtract. By the way, can you survive without this? Holly, it would be perfectly acceptable to go 1 or 2 or 3 or 4 or 5, write them all out, add them up. It would be even more acceptable, Amanda, to go 1 or 2 plus 281. But for what it's worth, total number of groups, 11 humans, choose 5 of them. We don't care about gender at all. Minus, looking at my bucket drawing here, can you, in your head, modify it so that we would have no females? Well, that would be 6 choose 0. If we're choosing no females, Andrew, how many males are we choosing then? That's the shortest way to get there. Everybody, every group of 5, every possible group of 5, minus any ones that don't have any girls, leaves any ones that have at least one girl. $11 choose 5 is 462 minus stop. Katie, stop. Remember from last day, what was anything choose 0? 1. What was anything choose itself? Also 1. In your head, without a calculator, Ashley, what's the answer? 461. Okay. So I'll try to show you some shortcuts. Now, if this was a test, you know what I would do? I would do it the short way. Hey, I finished the test. I got extra time. I would probably, on a separate piece of paper or somewhere else on the same page, look at each case individually, add them up, and if I got the same answer of 461 by going 1 or 2 or 3 or 4 or 5, I have to be right. Example 2. Consider a standard deck of 52 cards. Remember we said cards has 52 cards in it, 13 of each suit, 26 red, 26 black, 4 of each rank, 4 5s, 4 6s, 4 7s. How many different 5-card hands can be formed containing at least one red card? Well, what does that mean? 1 red card or which is perfectly doable. I think a shorter way would be to go all of them minus no red cards. Okay? 52 cards, choose 5. That's how many different 5-card hands. Remember, that was like 2.6 million. It was 2598, something like that from last day. Minus no red cards. Okay, ready? From 13, nope, not from 13, from 26 red cards, choose none of them. How many cards are left to choose from? 26 black cards, choose how many? Do you get 2533180? What we've really done is we found out how many black, I guess you can't call it a flush because a flush is the same suit, how many all black hands you can get. Subtract that from the total number of hands. Every other hand must have at least one red. What about at most 2 kings? What would at most 2 kings be? I'll give you a hint. 2 kings or, you know what? Only 3 things that I'll do the long way. I'll use a shortcut of like 5 or 6 ors. Here it was just 2 ors, 3 totals. Yes? So let's draw our bucket because there's 2 categories. We have kings and not kings. How many kings are there in the deck? How many non-kings are there in the deck? Sorry? 48? Okay. And you guys said at most 2 means 2 or 1 or 0. And you'll notice I'm not even writing the word or anymore. I'm just putting a plus sign there. All right, let's do the 2 first. So that would be choose 2. From 48, choose how many? 3? So the equation would be 4, choose 2, 48, choose 3, or... Okay, now we're going to choose 1 king. How many non-kings are we going to choose? 4. 4, choose 1, and 48, choose 4, or no kings, 5. 4, choose none, and 48, choose 5. Evaluate that. I'll do it up here slowly. Let's see if we get the same thing. You get 2594 400. Hey, do you guys remember how many hands were there grand total? 52, choose 5. How many hands have at most 2 kings? That many. How many hands have 3 kings or 4 kings? That minus that. There's your 3 of a kind king high or 4 of a kind king high. Right? C is surprisingly tricky. We're going to skip it. Turn the page. It says a class consists of 5 girls and 7 boys. A committee, by the way, I like this question a lot. You're going to get a committee question on your test. It's an easy way. You're going to get some cards, Amanda, as well, because I think it's a nice application. Many of you play cards. It's unfortunate. They used to do card questions on the provincial exam, which I think is just a great example because most of you have or seen or watched or played card games where you're interested in what are the odds. But about 8 years ago, certain very conservative religious groups complained, so they won't do card questions on the provincial exams anymore. Because some religious groups find cards offensive. Okay, whatever. So they went to all committee questions on the provincial, which is boring, but doable. Ready? Amanda, I'm going to pick on you. Yes, you. Class consists of 5 girls and 7 boys. A committee is to be formed consisting of 2 girls and 3 boys. How many ways can the teacher choose the committee if there are no further restrictions? Amanda, are there subcategories of boys and girls? Are there subgroups? This looks like a job for a bucket. Boys, girls. Amanda, grand total, how many boys do we have to pick from? How many girls? Okay, for the first committee, how many girls are we choosing? How many boys? What's my expression going to be, Amanda? Evaluate that, please. $350? Okay, Cassandra, now it gets a bit trickier. I'm going to pick on you a little bit. Johnny, the principal's not passing me on the committee. Teacher's pet. Okay. I'm going to combine fundamental counting principle, like drawing blanks and things, with this. So I'm going to start out by going, okay, there's Johnny. How many ways do I have to pick from Johnny, Cassandra? It's meant to be really obvious. 1. Now my bucket's going to look a little bit different. It's still going to be boys and girls. But how many boys do I have to pick from now, Cassandra? 6. Still 5 girls. How many boys am I going to choose now? Cassandra, not 3, 2. How many girls? 2. What's my equation? 1 times what? Okay. If now you have to be on the committee, how many committee can be from? Darn teacher's pet. By the way, you probably go second function enter, and I think you just change the 7 and the 3 to 6s and 2s and hit equals, yes? Because the 1 times in the front isn't going to make a difference. What'd you get? 150 or 115? 150? Oh, by the way, how many committees don't have Johnny? Tell me right now. No. How many committees don't have Johnny? 200. Right? Don't forget, you often have hidden useful information. You can use shortcuts. Okay. C. This is about as tough as they'll get. In fact, C probably might even be a little considered too tough. The twins cannot both be on the committee at the same time. You can have one, but not both. This question here, I can't find directly because this is a not question. It's saying cannot both be. What I'm going to do is I'm going to find out how many committees both twins are on, how many committees there are grand total, and subtract. My strategy is going to be this. Total number of committees minus the number that both twins are on. whatever's left should be any that both twins are not on. Is that all right, Itzel? Total number, now I'm not going to break this into gender. How many people are there grand total? How many people are there grand total in the class? That's how many ways there are of forming the different committees. Minus, okay. Now I'm going to have 3 groups in my bucket. Boys, girls, and twins. How many twins are there in the bucket, grand total? 2. How many girls? 5. How many boys? They pick gender-specific names. How many boys are left? I think we can assume the twins are female, are male. Yes. How many boys are left? 5. Now we want to put the twins on the committee, so we want to choose both of them. Oh, and how many girls do we have to have on the committee? And if both the twins are boys, how many boys are left to put on the committee? Okay, so if the twins both are on the committee, there are 5 choose 1, 5 choose 2, 2 choose 2 ways to do that. There are 12 choose 5 ways to form committees. Whatever's left will be one twin or no twins, but not both twins. What do you get? Mr. Dueck made a mistake. Mr. Dueck was having second thoughts here. He went back and looked at his notes. I forgot that the committees, I used the total number of committees. What I should have used is this 350, the total number of committees with 3 boys and 2 girls. Not 12 choose 5. Now what you get? $300? Anybody else? Oh, how many committees have both of the twins on it? 50. That must have worked out to a 50. Okay. Example 4 says, conditions which are equivalent. Jane calculated 10 choose 2 to be 45. She then calculated 10 choose 8 to be 45. They are the same. It says, explain in words. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That row and the front row are 10 people. There's a group of 2. How big is your group automatically? I can't form a group of 8 without forming a group of 2. I can't form a group of 2 without forming a group of 8. So that's why the number of ways of forming groups of 2, 10 choose 2, is also going to be the number of ways of forming groups of 8, 10 choose 8. In fact, 10 choose 3 is going to be the same as 10 choose 7. 10 choose 1 is going to be the same answer as 10 choose 9, because you can't form groups of 1 without also forming groups of 9. That's the explain in words. Mathematically, remember our choose formula? NCR was n factorial over n factorial, over r factorial n minus r factorial. That was on your formula sheet. So if I actually plug this in, this is going to be 10 factorial all over 2 factorial 10 minus 2, 8 factorial. This is going to be 10 factorial all over 8 factorial, 10 minus 8, 2 factorial. Nicole, are those mathematically the same too? Yeah, because on top of each there's a 10 factorial, and the bottom of each there's a 2 factorial and an 8 factorial. I mean, that's the mathematical proof, but the English proof makes sense to me. Yeah, you know what? If I have 20 students in here and I pull 3 of you out, I've automatically formed a group of 17 as well. Right? You can't form groups without forming ungroups. Or you can't be in without having people be out. D says, prove that. Nah. Example 5 says, solving for n in combination problems. Nah. And then they're going on this polygon, which is kind of cool, but nah. Homework. Number 1. Number 2. A, B, and D. I skipped C. 4 is good. 6 is good. Assuming you don't care what order you watch the movies in, you just want to know, did you watch it or not? Nah. 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 I think we're going to pause there. I also have for you a take-home quiz.